In the previous video, we talked about the data about central tendency measure like mean and median. But sometimes our data also have the contents that individual data points are distributed around those central tendency measure. That's why we need to know the measure of the variability, dispersion, and deviation. So those measures of dispersion explain the degree to which the individual data value are clustered about the center value. So then the degree of the deviation from the central value. So kind of is the variety or variance among all the data. Measure of the variability. We have four values we can think about. The first one is the standard deviation. Then it's range. Then we have interquartile range. We have the coefficient of variation. So we see one by one, what does that mean? The first thing, what is the standard deviation? The standard deviation, the definition is the square root of mean square deviation for all the observation from the mean of the data. The variance is the square of the standard deviation. Standard deviation, like the mean, get affected by the extreme value. So the first thing, like we say, your standard deviation is the variance. Take the square root. So the first thing, we need to calculate the variance. So the variance actually is each individual observe what's their distance from the mean. So here you will see the mu is represent the mean of the sample data. So the x is for all the observation. So we find the sigma. So using each value minus the mean, take the square root, then we add all those values together. So the same thing, we divide by n. So after that, we got the variance. But the variance actually is not the standard deviation because here, remember, you already squared. So that's why we're using the variance to divide, the variance to take the square root. That's why we got the low. So this low is we call the population standard deviation. So here, the capital N represent the number of the population number. So that's the population standard deviation. You use all the observer minus the mu. The mu is the mean of the population. So we take the square root, or we square that and add all together. Divide by n, take the square root. We have the standard deviation for the population. We also have the standard deviation for the sample data. So that's why here you will see a little different. Mu here represent the population mean. So here, when we talk about the sample, remember sample just part of the data, subset of your population. So the sample standard deviation is using the sample value minus, here we have the x bar. So this x bar actually represent is the average from the sample. So then you're using the standard deviation from the sample. But here we're using the n minus 1. When we divide, we don't divide n, we divide n minus 1. So the n minus 1, actually n is the sample size. So n minus 1 is the number of the degree of the freedom of the sample. So that's the definition about the standard deviation. So you can calculate by the definition for the standard deviation. You can either calculate the population standard deviation or sample standard deviation. Right, you will wonder, when we're using the population standard deviation, we divide the capital N, but that capital N is the number of the population. But when we're using the sample standard deviation, we divide by n minus 1 instead of the lowercase n for the sample size. That's because we're using the sample standard deviation to estimate the population standard deviation. We would like to obtain an unbiased estimation. observed sample value will be closer to the sample mean. So we feel like the sample number, maybe they have a higher variance. So that's why we decide in order to better describe to using the sample standard deviation to represent the population standard deviation, we're using the n-1 to divide a smaller number as compared to the n in the sample. So that's n-1 is we call the degree of freedom. It's the number of independent scores that go into computation of estimation minus the number of the statistic that we call the sample mean used to compute this estimation. So here is example, we find the standard deviation of the blood sugar count for a patient set. So that's why here, that's the value for the count. So in order to find the standard deviation, the first thing we need to find the mean for all the value. Then we subtract the mean from each value. So we square each value, then we find the sum. So then we divide by the sum of the n. So then we take the square root. So here we will see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the average will be divided by 11. So here you see here is the sample average. So we find the average about 58.36. So in order to find your deviation, so standard deviation, the next one we need to use each number minus this mean. Then we square that, then we add all together. So that's why you will see here is x minus x bar, the average for the difference. So then we square that. So then we get the total for all the square. But now, after we got that right, in order to get the standard deviation, we need to divide by the degree of freedom. So then be careful. When we do the mean, we divide by n. But when we do the standard deviation, we're using the total divided by n-1. So that will be 10. So then your standard deviation, your variance will be 295. To get the standard deviation, we take the square root. So that's the standard deviation equal to 17.193. So compared to the average is 58. So then your standard deviation is about 17. So from earlier, we see the example, your average, the blood sugar is 58, but the standard deviation, that means the spread is 17.19. So what does that mean? That means your average is 58, but the number, all the number variance, they are 17 away from 58. 17 away from 58 can be more than 58 by 17 or less than 15, less than 58 but by 17. So that's why most the value you will see they have the range is between your mean value plus your standard deviation and your mean value minus standard deviation. So that's you'll see that's the distribution they look like. So you can see very close because you see the value earlier, our number, you see they are between, that's why they mostly between 40.8 to 75. But sometimes, right, sometimes we have some outlier they may not really show, but most number you know they are in this range. So that's from the standard deviation, we kind of know the data distribution. So then you will see the next one we want to talk about the range. The range definition is the limit from the highest value to the lowest value. So that we really see the data here. We're using the smaller number and the biggest number. That's why we can see those values distribute between this range. So the measures of variability and dispersion and deviation, we have the standard deviation and the range. So the next one, let's talk about the interquartile range. Before we talk about interquartile range, we need to talk about the quartiles. So what is quartile? So the quartiles, one thing is we have all the data, we divide into 4. So that's why you have first quartile, that's 25%. So then you have in the middle. Then you have second quartile is 50%. So then you have third quartile is 75%. So how you will do, of course, you need to have all the value from low to high. Then after you align those low to high, you just need to see total how many number you have. So then we find the 25%, 50%, and 75%. So that's why, for example, the number we will arrange, you will see the number start from 39 to 100. Then since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 number. So that's why the third number will be the first quartile. Then the sixth number will be in the middle. So then here you will have the 75 on the third quartile. So that's the number we have. After you understand quartiles, right? Then we have the other definition we call the interquartile range. So the interquartile range is after we have 3 different quartiles, first, second, third quartile. We're using the third quartile, 75%, minus 25%, the first quartile. So this range we call the interquartile range. So what is interquartile mean? So the interquartile range, like earlier we said, that's the Q3, the third quartile minus first quartile. So after we got the interquartile range, actually it helps us to identify the outlier. So here is our definition. So our definition, in order to find the outlier, we're using the first quartile minus 1.5 times the interquartile. If any number less than this, they are outlier. Or if you have your third quartile plus 1.5 times interquartile range, so then they will be the outlier as well. So that's what we call the outlier. We use these two to have the boundary. So after you have that, you can calculate. So then we can find the lower bound actually is 20, about 20. The higher bound is 88.5. Then we can see earlier the data, 100 is an outlier for the data set. So after we introduce standard deviation range and interquartile range, so you can see the purpose for those statistic value. Standard deviation actually is represented by an algebraic equation, so can be manipulated algebraically. So here it takes all the data value into account. That will be used if the distribution is symmetrical. Standard deviation is sensitive if you have some few extreme value, that's outlier. So therefore it's not a resistant measure. We need to pay attention if we have outlier or not. So the range actually is very simple to calculate. So here, after you got your range, you kind of know how your data distribute. So the range is sensitive to few extreme value, and therefore is not resistant measure as well. But interquartile is after we find the 20%, 50%, 75%, the quartiles. So then you use that interquartile range. Actually, it's not sensitive to the few extreme value, because remember, you're only using the third quartile minus first quartile to get your interquartile range. So that's why this measurement is a resistant measure. So at the end, we have few seconds. I just want to show you, we talk about the coefficient of variation. Earlier, we talked about if you have a symmetric distribution, usually we say that's normal distribution. You have the mean equal to your median. But sometimes if not, we were using the measure of variance to determine the variation of variable related to the mean of the variable. So that's why earlier we have our standard variance divided by your mu, that's your population mean. So that we call the coefficient of variance.